Hey guys, Almin here. Gonna be doing the video on the execution step. I'm just gonna jump right in so I don't have to waste any time at all. A couple things to remember first. This is gonna be a comparison of the current Intel and AMD kind of execution structures. Looking at it like this is nowhere near the actual complication of how Intel and AMD currently structure their execution cycles, but this does give a kind of general overview. The reason I'm doing Intel and AMD is because most people watching this video will be more curious about these structures, about Intel and AMD current structures. Now to keep in mind, this is going to be kind of Haswell's overlooking structure, and it's going to be AMD Piledriver overlooking structure. It's just the current microarchitectures. There has been many occasions of AMD using elements from here and Intel using elements from here. Neither structure is really better than the other, just better at different things. Um, Obviously in ARM and PowerPC and all those different kind of instruction sets, there will be different execution structures, but they do usually follow a certain sequence of commands and orders, and it does go through this sequence usually. Now, on to the actual video. In my last video, I said there's something called a reorder buffer, and this reorder buffer basically tracks the status and the data of all instructions. Now, something in AMD's way of doing this, AMD's current Piledriver and Bulldozer, it has something called a retirement queue, which only keeps track to the status. Now, what is status? Status of instruction is basically what it is, whether it's floating point or integer or AVX or all that kind of stuff, if it's done yet, or if it's started yet, or if it's ready to be executed, and that's it. Or, kind of smaller miscellaneous things. Data, on the other hand, is solely what the instruction needs to be executed, what variables are needed, and the status of those variables. Now, in AMD's current architecture, the status is handled completely by the retirement queue, which is at the beginning of the execution cycle, while data is handled by the PRFs. PRF stands for physical register file. There is a PRF for every kind of register in the architecture. In Piledriver and Bulldozer, there's only two kinds of registers, which is for floating point registers and for integer registers. Now, what is integer and what is floating point? Integer is whole numbers, and floating point is decimal or half or not whole numbers. Now, over to Intel. What is the reorder buffer handles both status and data. Now, looking at these two first steps, what are they? They're basically their job of these two units over here. Their job is to basically keep the schedulers fed. On Intel side, you have a unified scheduler, and on AMD side, you have an integer and a floating point scheduler. Now, AMD side has actually more schedulers in the actual Piledriver. Actually, everything you're looking at here, besides like here, here, and here, and here, and here, and here, there's more of everything. And Haswell has 10 execution units, each with at least 3 functions. These are execution units. Haswell has 4 AGUs, I believe, and so does Piledriver. I'll explain what execution units are in depth later, what more of them later in different videos, as well as AGUs. Now, the job of these is to basically keep the big picture of all the instructions currently in the execution cycle and their statuses and whether they're done, started, or ready to be executed, and the conditions and how their operands are doing, if their operands are ready or not. Remember, operands is another word for variables, and if you don't know what variables are, that's a problem because you really need to know what these are. So take any algebra class and you'll very quickly learn what they are. Now, the job of these things are to keep the schedulers fed. Now, what are schedulers? Schedulers, think of it kind of like schedulers basically make things happen. It's very hard to explain. Schedulers pull everything together. Now, think of these are the execution units. These are the things that actually do that do the actual calculation. Sorry about that. These are the registers. So the registers are temporary storage we're working on right now. AGUs basically pull in and out information out of the caches and the registers. Now, let's say you get an instruction 1 plus b times c. Let's say this is an integer instruction. Let's say b is 3 and c is 4. Now, how would this structure work out? Let's kind of run this through each structure. In Intel, we would go to the reorder buffer. The reorder buffer would say, okay, this is an integer. We're gonna run it through the unified scheduler and tell the unified scheduler that it's an integer. It's an integer instruction. The unified scheduler, now its job is to basically make sure it's to schedule all the tasks that have to be done in order for this instruction to be executed. So first and foremost, what has to be done is B and C have to be present in the registers. Now, what is a register? A register is basically what's being worked on at that second. It is temporary storage for what's working on at that second. A good analogy would be, let's say you're a student doing math work. What is on the desk at that current second, what you're writing on the paper, all the tools you're working on the desk is your registers. What's in the desk would be like your L1 cache, what's in your bag would be your L2 cache, and what's on the other side of the room, like any extra supplies would be your L3 cache, and and so forth. So registers are what's being worked on at that second. The registers are over here. They are after the reorder buffer and before the unified scheduler. Notice how everything is kind of crafted or kind of molded around the schedulers, because the schedulers pull everything together to get all the work done. Now, as I said before, to complete this instruction, you need B and C to be pulled into the integer register. Why the integer register? Because they're integer values. You can't put them in floating point register unless it is a floating point instruction. So, the unified scheduler will tell the AGU. Think of the AGU kind of like an instruction, like in the fetch video. I said there's an instruction fetch unit. Think of the AGU like a data fetch unit. Now that isn't exactly what it is. I'll go in more depth on what an AGU is and what an AGU is, but think of it basically as a fetcher. An AGU is a little more in depth than that, but again, I'll go into depth that later. So the AGU will be tasked with getting B and C and putting them into the register. So the AGU first takes a quick look. Is B and C already in the register, or was this used recently? If it's not in the register, it'll go to the L1 data. It'll use the L1 data, the L1 data translation look-aside buffer, to quickly scan L1 data. If they're there, if B and C are there, it'll be pulled from B and C. It'll be stored into the AGU and deposited directly into the register. It'll then notify the unified scheduler, yes, B and C are now in the registers. So the unified scheduler will say, okay, they're in there now. The reorder buffer will be notified that this instruction will now be executed, and the B and C plus 1, this is basically this entire thing will now be sent down to the ALU, and the ALU will then do the work. So 3 times 4, pull this down, you get 12, 1 plus, and you get 13. So, the result is 13. And then once you have the result, it'll be put back to the AGU and then stored. Now, the store step is going to be explained in the next video. So we just saw how things would go in the Intel execution cycle. Basically, the instruction will come in. It'll be decided what will be done, if it's integer or register. If it's integer or floating point, everything will be figured out. The reorder buffer will pass the buck over to the unified scheduler. The scheduler will get the AGU to fetch the variables, which will put them in the register. Then the registers, and then the instruction plus the values of the register will be thrown to the ALU or the FPU if it's a floating point instruction. Again, there are many different execution units. It's not ALU only. There are also VBlend, FBlend, FMA, branch, and shift, and there's all these different names, which I'll explain some of them in a different video. But then once the instruction filled out with the variables are given to the ALU will do the work, get the instruction, and then it'll be stored, which I'll explain in the next video. Now, AMD. Things are a little bit different on the AMD side. Just a little bit. The retirement queue is only hold the status. So the retirement queue will get this instruction like this. It'll say, okay, this is an integer, we're going to throw it over the integer. That's basically it for the retirement. The retirement queue is that it's not used, it's not notified until the instruction is done. Its job is done. It passes the buck right over to the integer PRF and the integer scheduler. Notice how Intel has a unified scheduler for both integer and floating point instructions, and AMD has separated schedulers, one for integer and one for floating point. Just a quick note. Again, neither is really better, just different things. Better at different things. So, once the buck is passed over to the integer scheduler will ask the integer physical register file, what variables do I need? the PRF will say get B and C. Again, remember, data is stored over here, while in Intel, data is stored in the reorder buffer. So the integer schedule will say, okay, AGU, get B and C. So it'll search the register. If it's not in the register, it'll look through L1 data cache. Let's say it's not in the L1 data cache, it'll look through the L2. Oh yeah, it's in the L2. It's B and C right there. It'll get passed over to the AGU, get transferred directly over to the integer register. It'll tell the integer scheduler, yeah, you can now do this. Everything's there. Integer schedule will pull things right through the integer register right over to the ALU. The ALU will do all the work. I'm sorry, 1 plus 3 times 4, 12 plus 1, 13. So we now have the results, which will then be pulled over to the AGU, which will be stored and dealt with. So that was a lot. You might want to watch this video maybe once or twice. That's basically the difference between the current AMD and Intel cycles. Again, it does actually get a lot more complicated, but this is the bare bones. Again, this is a basics video. When I get into specifics and other videos, and I'll explain a little more in depth about those things. But this is basically what happens. A structure at the top that handles our status or data will get an instruction. They'll pass it to the integer scheduler, which will tell the AGU to get the variables. The variables will be deposited into the register. Then the integer will get the finished, or not the finished product, but the ready product, get it to the ALU. The ALU will turn it into a result, which will then be stored. And the store will be handled in the next video. So, that's that. So if you learned a lot, please like the video and subscribe. If you have any questions, comment or PM, or if you have any other ways to get a hold of me, do so. And yeah, I hope you understood the video. If not, take a look over it again. And if you still don't understand, ask a question. I'll always be happy to help. So thanks, and see you in the next video.